Hey guys. So in this video, I want to continue talking to you guys about system of equations, but I want to talk to you about system of equations in just a slightly different way. So last time we talked about system of equations, we talked about solving these systems, looking for that point where the graphs intersect. And that could be a very powerful way to find a solution to a system of equations, and we were able to find the solution to those systems of equations pretty easily. However, what I would say is that that certainly takes a lot of time, and it requires us to sit down with a ruler and graph paper, and it really is a little bit more difficult than it seems like it might have to be. And what we're going to start to discover over the next couple of videos is that we have an algebraic way to do this. We have a way to use algebra to find that point without always having to graph it. And there's two ways in particular that we're going to use, and those methods are the substitution method and the elimination method. But we're going to focus today on the substitution method of solving linear equations. So I'm going to move us to an example here where I can kind of show you how this is going to work. So let's take a look at an example. I'm going to go with y equals, let's do y equals 2x plus 5. That'll be one of our equations. In our second equation, I'm going to go with something like, let's go 3x plus y equals 15. Yeah, no, let's go 14. Cool. No, let's go 15. Sorry. So we're going to backtrack for 1 second, and we're going to go back and we're going to do this with 15 instead. And that's just kind of, I'm trying to make sure that we're going to get a nice, easy whole number answer here, so we don't have to worry too much about fractions and stuff right now. So the substitution method is really pretty easy to use, and it looks something like this. I have an equation that tells me that y is equal to 2x plus 5. So there's some combination of x and y that will make that equation true. In fact, there's an infinite number of combinations that will make that true. But there's one particular combination of x values and y values that will make my purple equation and my green equation both true. So since I'm looking for the situation where the purple and the green equations are going to both be true, it would behoove me to use substitution method, which allows me to say this. If both of these things are true, then I can combine them into one thing. Well, what is that going to look like? Well, I just told you that y is equal to 2x plus 5. So why not drop 2x plus 5 right there where y is sitting? Since the x's and the y's in both of the equations up there mean the same thing, or at least we're looking for that one point where they do mean the same thing, it is okay for me to plug part of one equation into another. So I'm going to say since y is 2x plus 5, then this equation, the green equation, can be rewritten as 3x plus, instead of y, I'm going to write 2x plus 5 equals 15. So all I've done is instead of putting a y in that equation, I've rewritten it, and I've plugged in what y is equal to, since y is equal to 2x plus 5. Those parentheses don't really mean anything. There could be a situation where they do mean something, but in this particular situation, there's nothing to distribute. There's nothing I can do to simplify. So the parentheses are going to go away, and I'm going to combine like terms, and I'm going to see that 3x plus 2x is 5x plus 5 equals 15. I'm going to subtract 5 on both sides, and I'm going to find out that 5x is equal to 10. When I divide by 5, I get x is 2. And of course, as we talked about in the previous video, the solution, the answer to a system of equations is always an x and a y. So there's a 2 in my answer, but I don't know what the y value is. And in order to find the y value, I'm just going to take that 2 and plug it back into an equation. So let's go up here and say, what happens when I plug 2 in up here? I get 2 times 2, which is 4, plus 5, which is 9. 2 comma 9. So that's how substitution can help me find that point where these two things are intersecting. Let's take a moment, though, and let's double check that. Let's go ahead and go through the process of graphing this equation and see if we agree or if we continue to get 2, 9 as our answer. So the first equation, the one that's in purple there, that purple equation says that y equals 2x plus 5, which has an intercept of 5, and it has a slope of up 2 and over 1, up 2 and over 1, or down 2 and left 1 and down 2 and left 1 and down 2 and left 1, etc., right? So that's going to give me this nice purple line here, which is really, really, again, not straight, and I apologize for that. Put an arrow on that end. And then I've got my green line, and my green line says 3x plus y equals 15. Well, 3x plus y equals 15 is not particularly easy for us to graph, but I can rewrite this in slope-intercept form. So I can take away this 3x on both sides and get y equals negative 3 over 1x plus 15. And now it's a little bit easier to graph. I would say that the only downside is that we're getting an intercept of 15, which is happening somewhere up here off my graph. So let's plug in some points to try to graph this one, since this one's not going to be terribly easy to graph. Let's see what happens when I plug in a, I don't know, let's plug in a 3. Let's make a little XY chart, and let's plug in a 3 and a 2 and a 1. Plug 3 in there. 3 times negative 3 is negative 9, and negative 9 plus 15 is 6. We plug a 2 in there. 2 times negative 3 is negative 6, and negative 6 plus 15 is 9, so there's a couple points. 3, 6, which is sitting right there, and 2, 9, which is sitting right there, and then this will continue with a slope of down 3 over 1 the rest of the way. And we're going to get that nice line right there. And of course, the place where these two things intersect is right there. And that point is the exact same point that we found using our other method, 2, 9. So using an algebraic method is certainly going to be a little bit faster than graphing it, and it's not going to require us to get out our ruler and our graph paper and all those things. So we're going to do a couple examples in the rest of this video where we're going to look at some substitution, and I'm going to ask you to potentially think about how we could use substitution to solve some of these equations. So let's look at an example here. We're going to have y is equal to 3x minus 4, okay? And then let's go ahead and go with 2x plus 2y equals 8. Let's go with that. 2x plus 2y equals 8. So thinking about what we talked about just a moment ago, we're going to go ahead and do substitution. So we know that y is equal to 3x minus 4, so we're going to plug 3x minus 4 in for y. And that's going to end up looking like this. 2x plus 2 times, instead of 2 times y, it's going to be 2 times 3x minus 4, because I just did substitution, equals 8. Notice that all I've done is rewrite this equation, but instead of the y, I've put 3x minus 4 in its place. All right, go ahead and finish this for me, because I know you guys can solve the rest of this. Go ahead and simplify this down and solve this equation for x. Cool. So let's go ahead and do this real quick and make sure everyone was on the same page. 2x plus 6x minus 8 equals 8. 8x minus 8 equals 8. 8x equals 16. And x equals 2. Cool. Am I done? No, of course not. Because as we said before, the answer, the solution to a system of equations is an x and a y. So I got to figure out what the y is, and to do that I can plug in my x. So let's go back to my original equation. Y equals 3 times 2 minus 4. 6 minus 4 is 2. So input 2, output 2. 2 comma 2 is going to be the solution that is true for both of my equations. Let's try another one. Y equals negative 3x plus 5. And let's go with 5x minus 7y equals 17. Let's go with that. Cool. So let's look for that solution. Let's go looking for that solution. So my first step is to do the substitution, like we've been talking about. And to do that substitution, I'm going to take what y is equal to, which is this thing, and I'm going to plug it in for y. And that's going to look like 5x minus 7 times minus 3x plus 5 equals 17. I've rewritten this equation, but instead of y, I've placed what y is equal to. We're going to distribute this negative 7, and you go ahead and tell me, what are we going to get for our x comma y? What is our final solution going to be? All right, so let's see if you got it right. We're going to go ahead and distribute that negative 7, and we're going to get 5x plus 21x minus 35 equals 17. We are going to add 35 to both sides, and we're going to get 26x equals 52. Divide by 26, and x turns out to be, again, 2. My solution cannot just be one number. It is an x and a y, so I'm going to take my 2 and I'm going to plug it in. Y equals negative 3 times 2 plus 5, negative 6 plus 5, which is negative 1. And my final answer is 2, comma, negative 1. Hopefully this has started to give you kind of a look into using substitution. Hopefully you've taken some good notes and you're going to be ready to talk about this next week in class. And certainly if you have any questions about this, feel free to come see me in tutoring or to speak about this in class with me next week. All right, have a good weekend.